Hello everyone, welcome to Mayur Programming Club. Today we will be solving another daily LeetCode problem, and the problem's name is rank transform of an array. So the problem statement goes like this: you will be given an array and you have to replace each element with its rank. Okay, and the rank of the element represents how large the element is. Okay, so the rank has the following rules. Rank of the integers will be starting from 1. Okay, and the larger the element, the larger the rank. Okay, so if two elements are equal, their rank must be same. Okay, so rank should be as small as possible. So from these points, we understand that the ranks should be the order in which the sorted ranks in the sorted order. Okay, for example, if let's say this is the array that is given to you. So let me copy it. So see, if this is the input array and if we sort this particular array, then it will be looking something like this. Okay, and if you look at the indices, okay, since it's a zero based indexing, if you add 1 to it, then you will be able to see their ranks. Okay, so 10 is having rank 1, 20 is having rank 2, and so on. Okay, so something like this. And when you will be result returning your result, you should be returning their ranks. So 40 is having rank 4, then 10 is having rank 1, and then 20 is having rank 2, and then 30 is having rank 3. So 4 1 2 3. Okay, so see, this is the answer indeed. Okay, but there might be a case that here the thing was it was pretty easy because the elements were not duplicate. So when the elements will be duplicate, this logic will fail. Okay, of just sorting the array and then seeing the indices. Okay, so what we will do is we will use some kind of data structure that will remove the duplicates and also maintain the elements in the sorted order. Okay, so two conditions for that data structure is remove duplicates and keep elements in sorted order, basically ascending order. So we do have that kind of data structure, and that kind of data structure is, since we will be doing the implementation in Java, although the C++ code will also be available, but that kind of data structure is tree set in Java. Okay, so since it is a set, so no duplicate elements will be allowed, and tree set, what it does is it stores all the elements in the ascending order by default. Okay, and the duplicates will be removed. So if the input is something like this, okay, then in that particular case tree set will only be having one element. Okay, and then what you will do, now you will ask that how we will be knowing the ranks of the element. Okay, you removed the duplicates, but how we will be keeping check of the ranks of the elements? For that, what we will be doing here is, let's say tree set is having some entries. Okay, let's say something was like something like this input was given. Okay, let's remove some part and see, instead of, let's say if, there was one another entry, 40 is occurring two times. Okay, so your tree set will be having elements in this fashion once you inserted them. Since for 40 was occurring twice, but here it will occur only once. Okay, and elements will be in uh, ascending order. Okay, so now you will initialize one variable rank and set it to 1. Okay, now when you will be doing the traversal of tree set and checking these entries one by one, you will be using one another data structure, and you will be mapping numbers with ranks. Okay, so see, key value pair kind of mapping is required. So in this particular case, map will be useful, so we will be using map data structure. Okay, so we will be using a inbuilt map data structure, and the number will be the key and rank will be the value. Okay, so when you keep inserting the values, let's say 10 was inserted, then rank value was 1, so it will be inserted like this. Then you will be inserting 20, this time rank value will be increased to 2. Okay, so 20 is having 2. Okay, similarly it will continue. Okay, just like this. So once you formed all the entries, and rank will keep changing as you are adding each entry. Okay, and so since there are not any more entries, so we will stop here, and your map will be looking something like this. Now you can query the map and get the corresponding rank of the element very easily in order of one time. Okay, and we will be doing the insertion very easily, so it will be looking something like this. Okay, 4 1 2 3 4. Okay, so this is how duplicates will be handled. Okay, and now let's see the implementation part. So for that we will be taking the code to the board. So this is the implementation. It's same as the logic is pretty same as we discussed here. Okay, the first thing that you will be doing is to remove duplicates. We will be using a tree set. Okay, and then we will be adding these entries to the tree set. Okay, and this, let's say the size of the array was n, so this whole thing will take you order of n into log of n, because each insertion is log of n, because tree set is maintaining the order for you. Okay, so then once you are done removing the duplicates and getting the elements in the sorted order, then you will traverse your tree set one by one and put the element and rank value mappings into the num rank map. Okay, number rank map. So each time you will be entering a element, you will be increasing the rank, so that next time the next elements is having a little higher rank, basically to be one higher than the previous. Okay, and once you are done with it, then you will just do a linear traversal of this particular array, and you will be also forming one array that you will be returning as your result, so ranks. And then once you will be doing the linear traversal, you will be getting each value, rank of each value of this input array. Okay, and inserting it into the ranks array, and you will simply be returning this ranks array. Okay, so this is the whole logic. And if we talk about the time complexity, so since this was the dominating factor, the insertion in the preset, so the whole time complexity is n log n. And since we will be requiring some auxiliary space, okay, both here also in tree set map, and this, if you are considering the ranks as also as auxiliary space, then it will be required, and it will be order of n. So these will be the complexities, and this will be the approach. If you are still having any kind of doubts or any queries in general, then you can ask them in the comment section. I really hope this solution walkthrough added some value to your journey of honing your DSA skills. Keep solving more and more problems, and I will be seeing you in the next video. Thank you for watching.